Respected judges, we are Team The Epic Bite from Jawaharlal Nehru Technological University, Anantapur. Today, we present FractureScan, an AI-powered system that detects bone fractures from X-ray images and explains its predictions using visual heat maps, enabling faster and more reliable clinical decision making. Now, let us deep dive into the problem statement. Basically, in emergency and rural healthcare settings, bone fractures are often missed or diagnosed late due to heavy patient load and human fatigue, and limited availability of radiologists. Subtle fractures are often difficult to identify, and radiology reports frequently take hours, especially in low resource hospitals. These delays increase the risk of misdiagnosis and improper treatment. Existing AI solutions are either expensive or hardware dependent or act as a black box systems, making them impractical and difficult for clinicians to trust. Now, the solution that we have provided is to address this challenge, we developed FractureScan, a web-based AI application that analyzes X-ray images in real time to detect bone fractures. The system uses an efficient net deep learning model combined with Grad-CAM to visually highlight the fracture affected regions, ensuring transparency and building clinician trust. The key features that we included is it delivers real-time fracture detection within seconds, provides visually explainability through Grad-CAM heat maps, and includes confidence score to support clinical judgment. The interface is simple and intuitive, and the system is optimized to run either on CPU, making it suitable for deployment in rural and low-resource healthcare environment. Now, the architecture from upload to insight. First of all, the architecture begins with a web-based front end where the user uploads an X-ray image. The image is securely handled by a Node.js backend and forwarded to an API-based AI service. Here, the efficient model performs fracture detection and Grad-CAM generates an explainable heat map highlighting the affected regions. The final output, including a prediction, confidence score, and heat map, is returned to the user within seconds. This modular and explainable architecture ensures scalability, trust, and real-world usability. The technology we have used here in front-end is React.js, Axios, and responsive UI. The backend services include Node.js and Express for the processing of model, fast API in Python, and the RESTful APIs are used. Next, for ML and visualization, PyTorch plus Efficient Net and Grad-CAM and OpenCV. Let us go through the prototype. Here, the FractureScan web page opens this way, where the user can upload by choosing image option from their local device. Next, when they have uploaded the image, it is displayed here and the analyze option shows here to analyze. The background pre-processing and model processing happens and the heat map is generated. Here we also have option to download the heat map and it can be saved in our local device. Impact through our innovation. FractureScan helps doctor make faster decisions in emergency situations by quickly identifying fracture cases without waiting for radiology reports. It is especially useful in rural hospitals where radiologists are not available, providing reliable diagnostic support at the point of care. The system can also be used during online and remote consultations supporting telemedicine. By clearly showing fracture regions using heat maps, FractureScan reduces the chances of misdiagnosis and helps improve patient outcomes. Now, key innovations. The main innovation of FractureScan is that it combines accurate fracture detection with a clear visual explanations. Unlike traditional AI systems, it does not act as a black box. It is lightweight, runs on normal computers without special hardware, and is designed to be practical for real hospital environments. FractureScan has the potential to transform fracture diagnosis from a bottleneck into a streamlined, confident decision-making processes. Now, the future roadmap. In the future, we plan to improve the accuracy of FractureScan by training it on large and more diverse datasets. We also aim to detect different types of fractures and integrate the system with hospital record systems using medical standards like DICOM. Additionally, we plan to deploy it on the cloud and extend the support to imaging types as CT scans and MRI. To conclude, FractureScan makes fracture diagnosis faster, more reliable, and easier to understand by using explainable AI. It is designed to support doctors in real clinical environments, especially where resources are limited. Thank you for your time, and we are happy to present this before you.